going to go ahead and I've upped the wire feed speed, and I've upped the voltage just a tiny bit, mainly the wire feed speed, to see if we can get a little bit better penetration this time. Here we go. Let me clean this off a little bit so we can look at it better. Yeah, that worked out a heck of a lot better. You can see here the line is good for fusion, and you see it's sitting lower than this one. This one was humped up a bit. This is sitting lower still. I just wanted to kiss this edge. Normally you'd want to overlap it a little bit more, but for the purpose of this demonstration, I just wanted to kind of lightly kiss it because I don't really want to get into this. I want to keep this as low as I can. This is better. Fusion is better. You see here we started at a lower amperage, and then we raised it and we raised it, and finally we got to here at one of the higher amperage ranges for the machine I'm using, and now we're at where we need to be. We've got a weld bead that's just a little bit thicker than the 1/4 inch that we're using, which is fine, and we've got decent fusion along the edge and good penetration, so I'm happy with that. Okay, the next one is going to be porosity. Porosity can happen for a number of reasons. The probably most common reason is because we forget to turn on our shielding gas with the MIG welding process. Another reason that porosity occurs is if we're MIG welding in an area that has a lot of wind. Any wind over 5 miles an hour will basically cause our shielding gas to blow away and will lead to porosity. Porosity happens when heated metal is not protected from basically air or oxygen. When that happens, when heated metal is exposed to air, it becomes porous and brittle. And any weld that happens to is basically useless. It has to be ground out, it has to be re-welded, because a porous, brittle weld will not stand the test of time. It will crack eventually, and it's basically not effective. So I'm going to go ahead and reproduce that. I've shut off my shielding gas, and I'm going to go ahead and lay down a bead so you guys can see what that looks like. Here we go. Okay, I couldn't ask for a more perfect example of porosity. First of all, you guys see how it welded. It was really smoky and spattery, and look at the end result. Just awful. I mean, all these little holes and craters, and it didn't fuse well at all. That's porosity, ladies and gentlemen. If that happens to your weld, the only thing you can do is completely grind that out and re-weld it properly, because this will not hold up over the test of time. Okay, next we're going to talk about too much weld deposit. Now this happens if you have your wire feed speed a little too high for the situation, and also if your travel speed is a little too slow. I usually advocate that it's better to err on the side of going too slow than too fast, because at least if you go too slow, or I should say if you go slower than you have to, you're guaranteed better fusion and better penetration, versus going too fast, you're probably guaranteed to not have enough fusion or penetration, and I think that's the worst of the two mistakes. But anyway, I'm going to go ahead and just hang on to this thing. I'm going to hang in there way too long, and I'm going to build up the weld bead as huge as I can, and let's see what ends up happening. Okay, as you can see, I laid in there so long that this thing is cherry red hot and it's taking forever to cool down here. Look at the immense width and buildup of this bead. It's almost like it's crazy. It's so wide. I just kind of held and held and held, and you would notice in the weld that it just kept spreading out further and further because it had nowhere else to go. It was just so much weld deposited material, so much wire I was putting in there that it just had to naturally spread out. Excessive weld material is bad for a couple reasons. Number one, if you're on the job, your boss isn't going to care for that too much because you're going to be wasting his money on a lot of wire that he didn't otherwise have to really use. So it's a waste of material, a waste of wire. But more importantly, what happens when you do this, I mentioned how cherry hot this got. Whenever you add too much and sit there too long, you're increasing the heat affected zone. It's getting extremely hot. And if you recall from some of my other videos, the heat affected zone is the most critical part of any welded member. Basically, if something is going to fail, if a weld is going to fail, it is going to fail in the heat affected zone. So the larger your heat affected zone, the more area that you have that can potentially fail. That's why it's so critical to keep that heat affected zone smaller. The smaller the heat affected zone, the less area there is to have a catastrophic event, shall we say. So definitely this is not good practice, any way you slice it. Okay, so as I was filming, I ran out of MIG wire, and I figured this is a great opportunity to show people how to load the MIG wire in properly. It's really not rocket science, but who knows, maybe there's someone out there that needs to learn this as well. Okay, I'm going to use the 12-pound spool, and by the way, in case I've never showed these before, these are Welpers, or sometimes known as MIG wire pliers, and they have a lot of functions. They're great. If you're going to MIG weld, you should have a pair of these. This area here helps remove the contact tip when it's hot. This area here squeezes around the nozzle so you can remove it when it's hot. This area here, you insert it into your nozzle and actually go around, and you can take all the sediment out of it. You can even kind of use this as this portion as a little bit of a hammer, and of course it can grab things. So I highly recommend these. Last but not least, the wire cutters here are what snip off your ends of the wire. So these are invaluable for MIG welding. Now you'll notice in here the spool holder has a little bit of an indent here, and if you look at the spool, there's the indent side here and the indent side there. I like to put it straight up so that I can then come in with the wire and get right in there. And I know if this thing moves with it, then I've got it. I'm right on where I need to be. This particular machine has this type of a spool holder, if you will, and it needs to be tightened in reverse. And that's so that it won't loosen while you're actually rolling it in the proper way. Okay, here, if you can see this, here is where the wire is. I'm going to go ahead and grab this now with my Welpers. And you want to make sure not to let go of this guy, okay? Very important. This wire is under a lot of tension. And if you let go of this, it's going to unspool itself, unravel itself. And I think I mentioned it before, if you get a spool that unravels itself, it's pretty much done. You can try to put it back and you can try to feed it through, but inevitably it'll catch and it'll stop the whole process. So unfortunately, if your spool unravels, you've got a useless spool. Now I've trimmed the end of this to get a nice clean tip, and I'm feeding it through here so I can get it into the machine and through the area of the guide rolls here. Okay, now here's the tricky part. You got to feed this through and then get the wire to pass into the liner, which I now have. Now that it's in the liner a little bit, I can push down on these rollers here, and that adds tension, and now I no longer have to hold on to this because the rollers will hold on to the wire for me. Okay, I'll make sure this tensioner is right, and I can feel that it's a little loose, so I'm going to tighten it just a little bit. Remember, we only want enough tension on the spool tensioner to make sure that this does not unravel itself. So in other words, if you give it a little shot and it doesn't start unraveling, we're good. I know that the tension on this is good from last time, but we'll test it. And let me go ahead and cut from here, and then I'll show you how we feed the wire through. Okay, so as you notice here, I've taken off the nozzle and I've taken off the contact tip. It's really the only way to for sure get this wire through here. If you try to do it with the contact tip, sometimes it misses and it gets bunched up in here and you can cause damage, and it's really just a pain. So I suggest taking off the contact tip to make it easy. Also, when I'm going to feed the gun, I make sure to keep it straight. No kinks, no twists, no unnecessary twists, because that doesn't make it any easier for the wire to get through, especially the end of it. So what I'm going to do is I'm going to turn the machine on, and I'm going to take my wire speed and I'm going to crank it up to maximum, because there's no reason for me to sit here and wait on a slow wire speed. So I'm putting my wire speed to maximum. I'm going to stretch this out and I'm going to pull the trigger. And here comes my wire. We're going to see it come out of the end here in just a second. There it is. Everybody see that? There's my wire. Okay? Now that the wire is through, I'm going to go ahead and feed my contact tip through it. Of course, we need to make sure that we have the right contact tip for the job. First, I'm actually going to trim this a little bit because I got a little too much here. And I'm going to take my contact tip and insert the wire into the contact tip and push it. Seems like we have a little bit of a feed problem here. Try that again. Sometimes what will happen is that you'll get a cutter that doesn't cut this quite right and bunches it up. If your cutters are not sharp and you smash the end of this wire rather than cutting it, it sometimes gives it a little trouble getting through the contact tip. So you got to watch for that. You got to have a sharp cutter. There we go. There we go. So that's what it was. My cutter is actually getting dull, and so rather than snipping it, it's smashing it. And that little act of smashing it is enough to keep it restricted from going through this actual contact tip. So I'm glad I showed you this, because there's a little real-life problem that occurred, and maybe it gives you a tip of how to deal with that better. Now all you have to do to make this run is to basically tighten your contact tip a little bit using your pliers. That's enough. Take a look at your nozzle. It's a little dirty, so I'm going to use my whelpers to come in here, clean it out a little bit, just to get all that gunk out of there. Great. Next thing I'm going to do is I'm going to show you guys how to use anti-spatter. It's a special type of stuff they sell at welding supply stores, but there's other things you can use it well. We'll get right on that in just a minute. Okay, what I'm going to demonstrate now that we have clean wire on here and we're just about ready to go is something that I think most people should use when they MIG weld. This is an anti-spatter nozzle dip, and you can see here I've got some of it. It's kind of ugly on the inside there because I actually have dipped it. There's a lot of schools of thought on this stuff. Some people say you shouldn't really dip it, and some people say, well, that's actually what it's for. I've done it both ways, and both ways it's helped me out a lot. So it's really up for you to decide. Now, the easiest thing to do here is to remove your nozzle. Take a little bit of this stuff, not much, doesn't take much on your pinky, and go ahead and rub it around the contact tip and on a little bit of the diffuser there. Now you got to make sure, you see there are holes here, okay, and these holes in this diffuser are to shoot the gas out. You don't want to get you wouldn't want to get a big clump of it like this and throw it on there, because then what's going to happen is you're going to block those holes in your diffuser. And if that happens, gas is not going to come through, and guess what? You're going to get porosity. So go ahead and just put a little bit on your pinky and run it like so. The other thing is your nozzle. You can see your nozzle here. You get a little bit more of this stuff. Run it on the outside of your nozzle, and using your pinky you can run it on the inside too. Now, when should you dip it? Well, I'll tell you when I normally dip it. If I'm doing some production work and I've got a lot of stuff going on, okay, I mean a lot of stuff, and I'm running bead after bead after bead and I don't really have time to stop, when this gun is good and hot, I dip it in there, and because it's so hot, it melts it and it becomes liquid. And in that case, you don't run the risk of it clogging it up because it's so hot, it just melts, it liquefies, and it just coats it. This stuff is non-toxic. It meets all safety regulations. It's silicone free, it's odorless, it's non-flammable. It's perfectly safe. I don't think I'd recommend eating it or anything like that, but you can touch it with your hands and you don't have to worry about that stuff since it's non-toxic. And you don't have to worry about inhaling any kind of fumes. The other thing I want to say is if you don't want to go out to the welding supply store and spend the money on that, you can use everyday household items like Pam cooking spray. Works just fine for the same thing. Or I even heard some people using Crisco shortening, same thing. Why do we use this stuff? Well, quite frankly, as you know, when you're welding, spatter comes back and shoots up on the nozzle and the contact tip, and sometimes that spatter can be a little bit of a bear to take off. What this stuff basically does is it makes it easy for that stuff to be removed so that you don't have to sit there and spend so much time cleaning your equipment. There are some people occasionally that like to use this stuff on welded material on pieces. In case any spatter hits the piece, then the spatter won't stick permanently, it'll easily come off. That's another use for this anti-spatter. Whatever you find use for it, I can tell you that I highly recommend it and I use it all the time. So think about using anti-spatter the next time you do your MIG welding. So that concludes our 4-part series on MIG welding troubleshooting. Listen, I really enjoyed filming this one. I hope everybody enjoyed watching it, and I hope a few of you learned something from it. We'll be back next week. Weld Fever Wednesday continues on, and thanks a lot for watching, and we'll see you then. Bye-bye.